Okay, this will be the video clip for problem number 3 in 1-3 rate of change of motion, acceleration. An airplane travels 3,100 kilometers at a speed of 790 kilometers per hour, then encounters a tailwind that boosts its speed to 990 kilometers per hour for the next 2,800 kilometers. What's the total time for the trip, and what is the average speed of the plane for the trip? So this is going to be a little bit of a review, both related to velocity and related to two-part problems. And hopefully you remember that for two-part problems, we're going to have to do a little bit of pre-work before we can get to our motion diagram. We're going to have to ask ourselves, first of all, what is it that we really want? And that is, we really ultimately want the average speed of the plane for the trip. And as an intermediate step, it wants us to figure out what the total time for the trip is. Since we need that information anyway, we'll just kind of roll it all into one problem here. So when we think about the average speed, we can start by writing down a formula that will cover the whole problem. We can say that velocity equals, and we know what velocity equals, right? It equals the change of position divided by the time. Well, in this case, we have two changes of position, right? We've got the 3,100 kilometer change of position and the 2,800 kilometer change of position. So I'm going to say delta x1 plus delta x2. In order to find the average speed for the whole trip, we need to know the total displacement, right? And the total displacement will be the sum of each individual displacement. Then we need to divide that by the time of the whole trip, right? We need the time for the whole trip, and so that's going to be t1 time 1 plus time 2, right? Okay, and we already know delta x1 and delta x2, so let's just go ahead and write that down anyway. That's 3,100 kilometers plus 790 kilometers. Okay, oops, not 790, my bad. 2,800 kilometers. Okay, but now we have to figure out the time, and that's what this problem really is mostly about, right? So since we have to do the same thing twice for both motions, we only really need to set this thing up once, and then we can use it for both. So I'm going to create a motion diagram. Now we're at that point where we need the motion diagram to help us collect information and put it in a form that we can use it. Okay, and so for the first motion here, our initial position is going to be 0, right? We're always free to set that to be 0. x0 equals 0, and then our final position is going to be at 3,100 kilometers. Okay, so our displacement will be 3,100 kilometers. So our delta x is going to be 3,100 kilometers. We also know that for this motion that the velocity is going to be constant at 790 kilometers per hour. So we only need one arrow for the velocity, 790 kilometer per hour arrow. And then it's not accelerating, so we don't need to put anything down for that. So our given information, just 3 pieces of information. We have an x0 of 0 meters, an x of 3,100 kilometers, and I should make that kilometers for meters, or for 0 too, shouldn't I? 0 kilometers. And then we have a velocity of 790 kilometers per hour. And we need, as we've already found out, we need time 1. Okay? And we don't have a formula that specifically identifies time, but we do have a velocity formula that we know that has time in it, so we can use that formula and rearrange the formula to find time. So I know that the Okay, so I know a velocity formula, right? V equals change of position delta x over t. And I can rearrange that to say that t1 equals delta x1 over v. And then I can solve, right? So I'm going to solve this. T1 equals, and my change of position is 3,100 kilometers. I went from 0 to 3,100. I could have also just used x here instead of delta x. And then v was 790 kilometers per hour. And if I make that calculation, I'm going to get 3.92 hours. Okay, now I know that my formula, the way that I'm going to do this, is going to be exactly the same for the next. I can still write down what my information is going to be, right? My initial position is x equals 0. My final position is 2,800 kilometers, and I can put that here, 2,800 kilometers, and then my velocity for the second motion is going to equal 990 kilometers per hour. Okay, so 990 kilometers per hour. And then I'm going to have the same formula, T2 equals x2 over v2, and T2 equals 2,800 kilometers divided by 990 kilometers per hour. That's going to give us 2.83 hours. Okay, and so then my total time, which is what they asked us to find first, T equals T1 plus T2 equals 3.92 hours plus 2.83 hours, 6.7. That's going to equal 6.75 hours. Okay, and then finally, to get that final velocity, I can put the 6.75 hours here, and then I'm going to divide, and 3,100 plus 2,800 is 5,900. So we want a total distance of 5,900 kilometers, and we did that in 6.75 hours. And that gives us 874 kilometers per hour. Okay, so that's our average speed, which is what we were asked for. Okay, so, and you would expect it that this is probably correct because it is somewhere between 790 and 990. You would expect the answer to be somewhere in between that, right? And this is. So again, this is how you do one of these two-part problems, and you find out what it is that you want to begin with, right? We want the overall velocity, and we know that the overall velocity is going to equal the overall distance or the overall displacement divided by the overall time. So since you have two motions, you have to sum each motion together. I have to sum the distances or the displacements, x1 and x2, and then I have to sum the times. And we were given the displacements, we had to figure out the times, and I showed you basically how to find those times in the way that we want to do in physics class. And then we added the two times together and got 6.75 hours, and we divided the overall distance by that, and we got our answer. Okay, let's go ahead and go to the next problem.